You all are welcome once again to Explicit Physics Academic. An academic that provides students to basic knowledge of physics and express knowledge in math as well. My name remains the same, Victor Odu. That's my name. It's theoretical physicist. So in today's kind of video, we're talking about unit and measurement. If you've not watched the previous video on how to do well in physics, I bet you are missing a lot because we've talked about the basic steps on how to do well in physics, and we explain everything out. Those hidden secrets, why people fail in exams, or why they complain, or why they're having some default. Before they explain it all out, and everything has been made clear. So if you've not watched those videos, you should do well. Go back, just pause, check the previous playlist, and go back and watch the previous video on how to do well in physics, because it will help you understand subsequent videos that we are doing, even the one we are doing as well. Okay, having said that, our topic still remains the same: unit and measurement. Unit and measurement. In far decades ago, some scientists have been having some misconceptions, some problems on how they could agree to come out with a consensus, a particular unit that they can use for all round to everyone within or outside the globe, like within different countries can use different skills, and it was actually affecting the world of science. So some societies now came up and said, okay, no, let us come and agree on a particular skill where everyone across the country, across the world, will use and calculate. Let's say if one person is using meter, another person will not be using a separate or a different measurement entirely. Let it all correlate. And that's why we are having the Systemic International. And that was done within 1960. And they came up with something of sort that we should come up with units that could rhyme across all our readings, whatever we are calculating. In as much as you are calculating, you are doing anything. But if you have not know this today, that physics is the science of measurement. You cannot know physics without knowing measurement. That's why unit and measurement is very, very pertinent and paramount to note. Okay, unit and measurement. You have to note the unit you are using in measuring all these things. So it's very, very important. Okay, so any measurable a quantity, because they are always measuring in physics. I want to know the weight. I want to know the length. I want to know the diameter. I want to know the thickness of this. What do I use? You're having different instruments, but I'm not getting into the different instruments we are having. I'm only talking about the unit and the measurement we are going to talk about for this particular video. How do I do this? I use either my spin balance, I use the band balance, chemical balance, whatever instrument I'm using to measure this. If you've not known about the different instruments that are used in measuring mass, you should check it out. Some are carbureted in grams, some kilograms, and so on and so forth. So you should check out those. So if you're measuring this, so people may use grams, people may use different units, but there's an agreed unit that you can use that can run across. That's why we are having unit and measurement. And of course, someone may ask, what is quantities? Quantities that can be measured. What are physical quantities? Physical quantities are those quantities that can be measured, are measurable things. These are quantities. Of course, we'll be asking, okay, what is this quantity we are talking about in physics? Of course, we are having velocity is a quantity. We are having displacement, we are having speed. They are all physical quantities because they can be measured, and and by you measuring them, you are having their units, and also they are all calibrated very, very well. Okay, so they are basically two fundamental quantities. Now, but before we get into the fundamental quantities, you have to note what is measurement. Measurement consists of a comparison between an unknown and a known quantity. How do I measure? I'm trying to compare this and this. And unknown. I don't know this, but I know this. How do I know this other market is right? That's measurement. They are comparison between an unknown quantity and a known quantity. And for you to know, and what is that quantity? Anything that is measurable is a quantity. Anything measurable is a quantity. That's why we're having physical quantities. Of course, we are having two different types of quantities. We have the fundamental quantities and the derived quantities. What are fundamental quantities? They are those basic quantities that are independent of any other quantities. Of course, they include we have the length, which unit is meter. That's the agreed unit for length is meter. Except perhaps you are looking at a very different perspective based on your experiment. Because some people use centimeter, some use different scale, but the agreed unit for length is meter. Of course, you are having the time, which is measured in seconds. You are having the mass in kilogram. You have the electric current in amp, temperature, Kelvin, the luminous intensity, and the amount of substance. Those are the basic fundamental quantities we are having. So as a science inclined student, you have to note these seven basic fundamental quantities. I've mentioned the seven already. So if you don't know them, do all. You're having the length, you have the time, you have the mass, electric current, temperature, and we have the luminous intensity and amount of substance. So those are the basic fundamental quantities we are having. Okay. So we also have the derived quantities. What are derived quantities? Derived quantities are quantities that can be expressed in terms of fundamental quantity. They depend on fundamental quantities. Remember, I've already told you earlier what are quantities. Anything that can be measured. And I've explained that we're having two different types of quantities. We have the fundamental quantities and the derived quantities. Those that are basic and the fundamental quantity, that's they don't depend on any other quantity, they're on their own. And we also having the derived quantities that depend on the fundamental quantities. So the derived quantities, as I've said earlier, we're having of course, we're having the area of square, we have the volume, we have density, velocity, acceleration. Those they are all combination of the fundamental quantities. So your knowing physics also depend on knowing these units. If you watch the previous video, I believe you've seen that one of the steps on how to do physics is memorizing units. These are the units I'm talking about now. You can see how they are correlating. That video is complementing this one, and this one also is complementing to that video. You can see how they are moving in correlation, right? Now, you have to know those units as well. The fundamental quantities, they are different from the derived quantities. The derived quantity depend on the fundamental quantity. Why the fundamental quantity why the fundamental quantities they are on their own basic, they are natural, and we are having more other derived quantities like the pressure, the power, the work, and so on and so forth. And of course, in your knowing physics, we having the prefix. The prefix is a sub multiple. Of course, let's say I'm trying to calculate something and it's giving me 0.000000, like up to 10 digits. Of course, I'll not come and fill up my book and make it look so rough and sketchy. But what do I do? No, I cannot just come and use like up to 1,000 zeros. No, I can shorten it. That's why we are having prefixed. We are having Ezra, we are having pentra, we are having nano, we are having micro, centimeters. Those are all in the negative axis. That is, we are having 0.00, and you want to convert it to standard form. You can either attach to your symbol as Ezra, nano, pico, micro, and so on and so forth. We are having so much. So when you look at that, you see that it's very important that you note what you are doing. And also, if you are calculating and maybe your values you are getting is giving you large value of positive values, of course, we are having them so much. We are having large positive as kilo, we are having mega, we are having giga, we are having tera, we are having pentra, we are having ESA. That's bigger values. We have like positive big values. But when we're talking about the negative, talking about the centi, we having the milli, we having the micro, the nano, the pico, the femto, and the atto. Of course, that may sound so weird, but that's atto, and it's times 10 raised to the power of minus 18. And we having femto, of course, times 10 to the power of 15 minus 15. That's if you're calculating your readings and it's giving you these small values, of which I believe for you to get these small values, you have to be dealing with the atomic physics, because atomic physics discusses little particles, and for you to get these small particles, that means that you're actually dealing with micro physics, like nano substance that cannot be viewed with the ordinary eyes. Of course, you can calculate how bigger values. That's why we're having the kilo, the mega, the giga, and so on and so forth. So if you look at those things, or you see that they are very important to note all this because they will make your work look neat. Of course, we are having units things that are used in measuring length. You can use the vernier caliper, meter rule. We can use the micrometer, screw gauge, and so on and so forth. The other units, we are having units measurement of mass. You can use the spring balance. You can use the beam balance. You can use the chemical balance. You can use all of them. They are calibrated differently, and it's based on what you're calculating. There are some instruments that can calculate micro mass in grams and others like that of sort. Of course, we are having measurement of time. They can be used quarks. We are having the simple pendulum watches. We are having uh, the ticker tape timer, and so on and so forth. We are having so much instrument. Why am I constrained to these three basic quantities? Because those are the basic fundamental quantities. And as a science student, you have to note the instrument using measuring them. Like I've talked about the length, you can use the meter, you can use the micrometer, screw gauge, you can use the vernier caliper to measure even small length. The length of a wire, you can use micrometer, screw gauge. Of course, I've talked about how to measure mass. We're having the beam balance, the spring balance. We're having so much, and also time. Of course, we're having stopwatches, stop clocks, and the ticker tape timer. I believe all these things I've discussed of the units. Why we are doing units, the measurements, what is physical quantities. I've talked about physical quantities as anything that can be measured is a physical quantity. And also we are having two basic types of quantity, fundamental and derived. I've talked about different examples and the basic fundamental quantities. I've talked about derived quantities. There are many, but at least I've listed a few that will help you. So do well as much as possible to subscribe to this channel if you've not done that, because we're doing so much in explicit physics academic. If you want to get us on Facebook, go to Facebook and search for explicit physics academic. If you want to also get us on our email, www.explicitphysicsacademic@gmail.com, we are also live there. You can as well drop us a message if you've not replied to your comment on the YouTube, of which we will try to reply to all messages being dropped on the comment section. You can drop your questions there and also email us. You can also message us on Facebook. We are always there to attend to individuals, to all students across the globe. Don't be left out. Subscribe, like, and also share. Thank you. I see you next other time.